Hey guys, I split up this VOD into two. It was a little long. I didn't want you to have to sit through two without a break. So this first one's on kinetic theory, and the next one's going to be on states of matter. You need to watch both of them before next time. The one on kinetic theory is going to explain the states of matter, so please make sure you watch that. There's a lot of forces that you need to understand that are at work here. So watch the kinetic theory one and then go into the states of matter. It's going to give you a lot better understanding of what you need to do for it. Alright? I can't find the off button right now. I'm a little lost. Alright, so we're going to start with kinetic theory. And what kinetic theory is the theory that all the particles within matter are moving. And we know what those particles are called now. They're called atoms. Or those atoms make up molecules, and those atoms and molecules are moving, and it may seem imperceivable to us, but even the desk you're sitting at school, those particles are vibrating slowly. And we call that movement kinetic energy. And what that is, whenever you hear the word kinetic, you think of movement, whether it's kinetic theory or kinetic energy. I think of calisthenics, stretching from PE. You're moving, just like kinetic energy or kinetic theory. It's all about movement. And what we're talking about here is those particles, again, the atoms and molecules, they're undergoing collisions. So we have particles moving at one another, and it hits one, and then it moves into another, and then it hits another. And what happens here, these are perfect elastic collision. And what that means is there's no energy lost. It's almost like think of billiard balls. Here, I'll put an 8 on this one. Think of billiard balls hitting each other, or pool balls hitting each other, and they take that same force relatively, and they push the other one at that same with that same force. So that's kind of how you can think about these atoms slamming into one another. And for a good example, oxygen in the atmosphere. Oxygen atoms run into one another billions of times within a second. So there's all kinds of these collisions, and we can control those collisions, and we can increase the speed, we can decrease the speed, and we can do that by controlling the temperature, the heat that's applied to that matter. And we can also do that with pressure. Now, we need to figure out what those things are before we move along, so let's discuss that next. So let's talk about temperature. Temperature is the measurement, and this is the key word, of the average kinetic energy of the particles. And so you have to take a look at what kinetic energy again is, and that's again dealing with movement. And so the equation for kinetic energy is right there. It's 1/2 mass times velocity squared. So we're looking at the mass of something, and we're looking at the velocity or the speed of something. So again, kinetic energy is dealing with the speed. And the faster it moves, the more kinetic energy it has. The slower it moves, the less kinetic energy it has. But you're also dealing with the mass there. So there's not a lot of kinetic energy built within these individual atoms, because as we went through this, the mass of them is so small. And so what we're looking at here is these particles, again, are running into one another, and the energy is transferring from one atom to the next. Energy is another term you need to know. It's an object's ability to do work. And so you may want to think about, okay, well, what's work? Work is the force applied over a distance. Okay, so it's a lot of physics terms here in our chemistry unit. You have to know what force is to understand what energy is. So force is mass times acceleration. So again, we're going back to that mass. So really we're looking at mass and force applied over a distance is work, and energy is an object's ability to do work. So if there's force applied over a distance, then we're talking about energy. So what's the difference between heat and temperature? We've just brought up both those terms in a previous slide, and you have to understand there is a difference, and this will come into play when we look at a graph on phase changes. Heat, or thermal energy, is the overall kinetic energy of the particles in a substance, while if you remember from the last slide, temperature was the average amount of kinetic energy within the particles. So what we're looking at here is heat is a kind of a more of a larger term, looking at the particles as a whole, as a sum, while temperature we're looking at the average. It says here, is heat the only variable affecting particle movement? So as I mentioned before, you can affect particle movement by either adding heat, taking away heat, or adding pressure or lowering pressure too. Yes, there I am under pressure. My head is pounding. So pressure is, again, the force on a given area. So we have pressure causing particles to expand or condense. So basically, if we had a jar here and we had a lid that can move up and down, let's say this is my lid with a plunger that can move up and down, and I push that downward, and let's say here are my little particles in here, my little gas particles, and they're bouncing around off the container walls, and now I push this down and it's much lower. Well, what I've done, I've compressed these air molecules, or these gas molecules in here, and so they're bouncing off the container a lot faster because, well, there's less volume. So they're moving around and hitting the container and hitting each other at a lot more greater rate than they would have if I take away that lid and bring it up. Then they would escape if I brought the lid off, or if I pulled the plunger back, then they'd have more room to move. So they would actually kind of bounce off at slower rates. They would hit the walls less frequently, hit each other less frequently, because there's more volume. So we can also change particle movement by dealing with pressure.